I think it'll look familiar, but worth going over for sure. But we're looking at multiplying and dividing rational numbers, which really rational numbers, we're really just saying decimals. So you notice Roman numeral 1 and 2 are decimals, and then rational numbers also include fractions. That's Roman numeral 3 and 4. So multiplying and dividing decimals and fractions is really the section. Ready? Mm-hmm. Cool. So when we did the adding and subtracting fractions in the last section, we talked about how you had to line up the decimal points. So I wouldn't write this down, but if you have like 32 plus, or 0.7, 32.7 plus 3.14, you line up one decimal point right above the other. My 4 is a little bit over, but the 1 and the 7 should be lined up. These two should be lined up and so on. Good? Mm-hmm. 4 is lined up with a 0. You don't have to line up decimal points this time around. So I'm going to erase that and say you don't need to line up decimals.
What is what's not?
You multiply like normal. The total number of decimals in the answer equals the total in the original numbers. So back on track. So for multiplying these two, I'm going to go and write them one above the other. So 42.7 times, I'm just going to do the 0.12. Make sure the decimal points show up. Kind of jumping ahead to the answer, we have a total of 3 numbers to the right of the decimal, right? Mm-hmm. So we have 3 decimals before total. We're going to have 3 decimals in our final one. The multiplying is just what you've been doing for years. So we do the 2 times 7 is 14. So we put the 4 there, write the 1 on top. 2 times 2 is 4. Add the 1 gives me 5. 2 times 4 is 8. Everybody's good for the first line? Mm-hmm. Seems like you guys are all in the habit then of putting a 0 here before you start your next digit. So then you could do 1 times 7 is 7. 1 times 2 is 2. 1 times 4 is 4. So far, this part down here in the bottom is just what you've been doing for years and years and years. Agreed? Mm-hmm. Or maybe years and years. I guess not when you start. But then add them together. 4 plus 0 is 4. 5 plus 7 is 12. So carry the 1 over to there. Gives us 11. Carry another 1 and a 5. So if we didn't have decimals, if it was just 427 times 12, the answer would be 5,124. But because we have a total here of 3 decimals, we need to have 3 numbers to the right of the decimal there as well. So the final answer ends up being 5.124. Work for you? Mm-hmm. And if the multiplying is like, what? I could help you with the multiplying later, but I'm going to kind of assume that you know that stuff. So, all right, dividing decimals. Try coming up with what's a one sentence thing that explains it. So we'll see how clear this ends up being. I'm going to say move decimals. I'm going to do an arrow to the right, so move decimals to the right, and line up in answer. If that's as clear as mud, we'll do one and see if that ends up helping. So 0.4092. So 0.4092 divided by 0.12. So it starts out looking like that. Fair enough? Mm-hmm. What I mean by the move decimals to the right, this thing here, is that we take this, and this has to go 2 jumps to the right to end up there. If we move that one 2 jumps, then we move the other one 2 jumps as well, yes? Uh-huh. Essentially, we're just multiplying both numbers by 100. And then the line up in answer by that thing right there, I mean you just copy that decimal point straight up there in your answer. So move the decimal point of that first number over until you hit the bracket. Move the other decimal point number over until you get to the same spot. And we end up with this for our problem. Good? Mm-hmm. So then 12 goes into 4, not at all. So then you say 12 goes into 40.
Twice. No,
3 times. 3 times. Okay. Gives us 36. Good call, Nate. So we subtract 40 minus 36, and we get 4 left over. Copy the 9 down, so we have 49. How many times can 12 go? 4, yep.
48.
Because 12 times 4 is 48.
Yeah.
So we put a 4 above the 9 then. And we have a 48. 1 is left, and we can drop our 2 down. 12 goes into 12? Once. So final answer then would be 3.41. write it over there because I'm a little squished above. But dividing look okay?
Yes, sir.
Cool. So that's the decimal part. Then we just have the last two things. What happens now as we switch over and do this with fractions? So mixed numbers are just like this number here in front, right? 2 4/5. So if you have one of those, first step is to change mixed numbers to improper fractions. And I didn't really write anything about the multiplying. I'm going to say change numbers, mixed numbers to improper fractions. Then I'm going to say then reduce, then multiply. So change mixed numbers to improper fractions, then reduce, then multiply. You can multiply and then reduce, but I like reducing before I multiply because then the numbers are all smaller. In my final answer, I'm reducing smaller numbers. So yeah, so it might be worth adding something like don't need common denominators. That's why I prefer to multiply and divide than add and subtract, because common denominators are just a pain, I think. So let's do this one. So 2 4/5. We're going to first take that 2 4/5 and make it something over 5.
12.
Close. 2 times 5 is 10.
14.
We multiply those two. And then we add the 4, so 14 over 5
Good try.
times 1/4. And by reducing, you're looking and saying, can anything in the numerator and something in the denominator be divided by the same number? Are they divisible by? And usually it's diagonally that you can do that. Usually the vertical's already been taken care of. But 14 and 4 are both divisible by?
4. 2.
Not 4, because 14 can't be. Yep. But by 2, you could divide by 2, divide by 2. And if you were to do that, 14 divided by 2 is 7. 4 divided by 2 is 2. So usually people don't rewrite it. I'm going to rewrite it just so it's a little more clear what's going on. But 7 times 5 over 1/2. Still good? And when you have that, multiplying, what's nice about multiplying, you don't need common denominators. You just change it into like one big fraction. Multiply the numerators, multiply the denominators. So 7 times 1 is,
7.
and 5 times 2?
10.
10. Nice. And if you can reduce at the end, if you can reduce this, do it. But if you've reduced everything in here, kind of like we did there, you reduce completely here, your answer will automatically be reduced for you. So, good. You might have like an improper fraction you change back into like 3 5/7 or something, but we'll get that in the next one. Dividing. Dividing is just one extra little step and kind of one thing to remember, but it's really not any tougher. So dividing by a fraction is the same as multiplying by its reciprocal. And reciprocal just means that we're going to flip that second fraction. Numerator becomes denominator, denominator becomes numerator. I do want to put a little note in here, though, is I'm going to say change to multiplication. So you have to flip it first, change the multiplication, then, in all caps for dramatic emphasis, simplify. So if we do this one together, 2 5/8, that is the same as 2 times 8 is 16 plus 5, 21. So we have 21 over 8 divided by 1/6. The most common mistake I see here is people look at this and they think, ooh, the 21 and the 6 are both divisible by 3. Then they'll reduce now, but you can't reduce now. You have to first flip this thing to change it to multiplication. So that's the same as 21 over 8 times 6 over 1. Now you can reduce something in the numerator with something in the denominator. So we can't any longer reduce the 21 and the 6 because they're both in the numerator, but we can reduce the 6 and the 8 by dividing them both by 2. So if we divide 6 by 2, we get 3. Divide 8 by 2, we get 4. And we can't reduce the 3 and the 4. We can't reduce the 21 and the 4. So now we just multiply. So make it into like one ginormous fraction. And you get 21 times 3, which is 63. So we're just doing 21 times 3, And 4 times 1. Good so far with the 63 over 4? Now we just say, how many times can 4 evenly go into 63? I do it this way. 4 can go into 40 10 times, right? Do you agree 63 is at least 20 more than that?
Mhm.
So if 40 is 10 times, 20 is going to be 5 more. So 4 times 15 then would give me 60. So the 15 takes care of 60 of my 63. How many of the 63 are left?
3.
Perfect. So 15 and 3/4. I think a lot of them won't be as big as the 15. But questions we should look at all together? Awesome.